Hello everyone. So in this video we'll be speaking about something quite different from computer organization, I would say, but I'm trying to cover these topics just because they are quite included here when we are speaking about the design of computer organization. Some of the basics that I'll be discussing in this video would help us to go on in understanding the development of different objects of computer organization, wherein it makes a lot of difference, and there are a lot of importance with respect to having those designs and understanding those designs in learning the other organization process in a better way. So this is about a small introduction to arithmetic that are involved in computer operations. Okay, so we see what all the different arithmetic operations we would find. First of all, the first thing that we should all know is that how arithmetic operations are considered, how they are operated. If you all know, arithmetic operations will have bits, so it will not be a regular arithmetic numbers. When we actually speak about computer operation, we speak about binary operation, right? So here we see that this is your binary operation. There is an n-bit vector we have. If suppose we have an n-bit vector, so that n-bit vector will be represented with respect to bits, where we'll be having the least significant bit at the rightmost, and we'll be having the most significant bit on the left side of the bit string. How do we value it? When we speak about value, it is about individual positional values starting from 2 power 0 to the left hand side, will move increasing the powers of 2. So we all know that. Other than that, when we have to represent any numbers, maybe a positive number or a negative number, which are quite important with respect to numbers, so we go for two things. One is that we go for three things actually. Two things only. Let me say three things. The first thing is that signed and magnitude. So we speak about the signed numbers. We have got two categories. One is called signed numbers, the other one is unsigned numbers. We have, since we are supposed to represent the positive and negative numbers, we will go for that signed numbering. Okay, that is the first one. The second one is complement operation. The complement can be 1's complement or it can be 2's complement. Okay, so we have both the representations. I hope you people know about the complementation. So I'll have a small discussion on that also in few minutes. So with respect to this, with respect to signed numbers, we say the sign of the number is represented by the most significant bit. Whatever that we spoke here, this is the most significant bit, and this represents the sign. So how a sign is represented? If suppose the bit is 0, then we say that is positive. So the number is positive. If suppose the bit is 1, then we say that the number is negative. So we should remember this. This is the important thing that we should always know. Okay. Let us see how we are supposed to consider all those numbers in order. So this is a small representation of having values. If we are speaking about signed numbers, this is how we represent it. So we have plus 7 and then we stop at minus 7. We have another option. That is, if suppose we are speaking about unsigned numbers, then instead of having this as this factors, we will start it here as 8. This becomes, or this value completely becomes 8. So that is the speciality. And we end here as 15. So we should know that difference. Right? If we are speaking about signed numbers, then we are speaking in a different way. So 0 to plus 7 and 0 to minus 7. These are the two numbers. If you are speaking about 1's complement, then this positive side will never change. Remember this positive side will never change. But the negative side will change, because when we take the complement, all zeros becomes 1's and all 1's becomes 0. That is in our 1's complement. So we speak about 1's complement. Let us not worry about 2's complement for now. So in 1's complement, that is the point. So 0 becomes 7. So this becomes vice versa. This turns out to be the other way around. Right? This is your 1's complement. But in 2's complement, we all know that we try to add 1 to the least significant bit. Since we add 1 to the least significant bit, this value gets incremented in a way, or we can say decremented by 1 value. Therefore, we have minus 8 to minus 1. And this is the perfect sequence of representation. Why? Because there is no minus 0 and plus 0 in our number system, where we are wasting a lot of space here. We have minus 0 here, we have minus plus 0 here. Not required. Here, if you observe, we have only plus 0. This is the speciality we go with for 2's complement. Okay, this is how we represent numbers with respect to 1's and 2's complement. The next thing is that we speak about addition. We have two basic operations. One is addition and subtraction. And if you all remember from your basics, like maybe in your first year engineering or in your 12th, you would have heard about something. And I assume that you people have got the basic idea of binary operations and all that. So if you all remember from that memory, then here we have two basic operations. One is addition and subtraction, where subtraction can also be done by using addition. So that we call it as complement operations, right? So this is one of the small example that I have taken for arithmetic addition. So we are adding only one bit. If suppose we are speaking about 1 plus 1, we have 0 as the sum and 1 as the carry out, right? So if suppose we are adding only two opposite bits or common bit as 0, then we will get only the answer in one bit. But there is only one special condition. If we are adding two maximum values, then number of bits will also be increased by 1. So that is the speciality in addition. For multiplication, if you are speaking about it, because it's almost like double, right? If you all remember, if you want to multiply two numbers, maybe 2 into 2. If you multiply 2 into 2, you will get the value to be 4. That's all, right? But in terms of your decimal number, the maximum number that we have is 9. So if you multiply that 9 into 9, the answer is coming out to be 81. So 81 is of 2 bits or 2 digits, whereas 9 is a single digit and the other 9 is also single digit. So that is the reason we need to worry about, if suppose we are multiplying two maximum numbers, then the number of bits becomes double. Here it increases by 1. For addition, it increases by 1. Okay. This is the first thing. So when we are speaking about numbers, we are supposed to consider the numbers in two different modes, or we represent that in terms of mod n. If suppose the numbers, you all know that, right? Mod n operations. If suppose we are supposed to represent 3 in binary numbers, then the number representation will be 1, 1, because 3 divided by 2, we will get 1 as the quotient, and 1 as the remainder, which we are supposed to combine. It becomes 1, 1. So that is your mod n operation, right? So we can represent that number like this. This is your representation of mod n operation in 2's complement system. So you should remember that we are representing it in terms of 2's complement number system. This is what we saw just before in the previous slide. So let us consider some addition and subtractions here. So this is your simple addition. If you observe, we are trying to represent the digit with its sign. Remember, we are speaking about sign numbers. So 0010 is not just 2, it is actually plus 2. Similarly, 0011 is not just 3, it is plus 3. So when we have two common signs, then it gets added up and sign remains the same. So 2 plus 3 is 5 and sign remains the same, and this is working out. It's perfectly right. 0 represents the positive number and 101 represents 5. Very perfect, right? So, but when we are speaking about the other kind, that is, we have a positive in the one side and we have a negative number in the other side, we are doing the operation of addition actually. But when we have two different signs, then we check for the difference. Remember that we check for the difference, and the number with the maximum value, the sign of that number remains for the result also. So we here 6 is more than 4. The sign of 6 will come to the answer. And the answer is the difference. So 6 minus 4 is 2. So we have the answer here also. That is, if you observe, this becomes the sign and this is the answer. It's very perfect, right? So this problem, here we have a problem. The problem is that if suppose we have unknown or two different or common signs having two maximum values. If you observe this C and D, we don't have much of a difference there. If you observe minus 2 and minus 5, the answer is minus 7, it's perfect. Plus 7 and minus 3, the answer is plus 4, is also perfect, right? Here, if you observe, when we are adding it, 1 plus 0 is 1 here, and 1 plus 1 is 0 with a carry of 1, and again 1 plus 1 is 0 with a carry of 1. Then we have 111. We have a carry here, but we are not worrying about it. We are neglecting the carry. Here also the same thing happens. One carry will come and we are neglecting it. But here, if you observe in the example that is E, especially, here we have -3, -7. What should be the answer? It's a very simple question. So when signs are same, we need to add them. But if you observe, we have given an operation here. There is an operation of minus, and there is a sign for 7. So minus into minus becomes plus. Remember that it becomes plus. Can you observe that plus 7 here? Right? How did we get this? This is nothing but the 2's complement of the given number. That is a speciality, 2's complement. All 1's becomes 0, all 0's becomes 1. So if I change this to 1's complement, it becomes as 0, 1, 1 and 0. For this I need to add plus 1, right? When you add plus 1, you'll get 0, 1, 1, 1. So that is what you have, 7. So if you try to operate these two things, then you will automatically get as 0, 1, 0, 0, which is nothing but plus 4, which holds good for this operation. It's perfectly right? This is how the speciality of numbers that we will speak about. So here there are two things, extra things that we should know. That is, one is overflow, the other one is character. The overflow is nothing but, in the previous slide, if you have observed that, so we are getting this one extra bit. This is your overflow. For this could be a overflow. For many different things, the overflow happens changing the value of the sign, which is not fine sometimes. That's a problem for us. Let us consider, like, I'll add 0, 111, added with one more 0, 111. So the 0, 111, 0, 111, we should get a 7 plus 7 to be the 14. 14 is nothing but 1110, right? We should get the answer. When we get the answer, we see that like it becomes 1110, right? The answer is 1110. But if it is a signed number, then we consider this as this is a sign and this is the answer. So the answer becomes -2, which is not okay for us. Even though we are adding it, signs are fine, everything is fine, and we get the answer to be -2, which is a wrong answer, right? This is called overflow. The sign of any number gets changed because of the lower value bits getting occupied into the maximum MSB. So when it gets tried to occupy the MSB, it actually changes. So this is the problem, and we call it as overflow. So overflow can occur when adding two numbers that have got the same sign and higher in value. Okay. The other one is the carry out. To get the sign significant, we should always have an indicator overflow, which actually tells us about the sign number. The other kind of representation that we would be considering is characters. The computer variable that we are considering may not actually handle only the digits. Sometimes it may have to actually deal with characters. Characters, like you all remember that you try to publish an unknown variable or a temporary variable, you call it as A, B, C or something like that, and you try to assign a value to A and you try to operate everything with A. So this speciality characters, whatever that we are supposed to deal with, must also be sometimes considered. So we have got some characters that we can consider. The characters can be your alphabets or some decimal digits or punctuation marks or any special characters and so on. So we cannot have those things as binary digits. So how do I have to represent all those characters? For that purpose only, we are going with something called as the ASCII value. The speciality of having an ASCII value is to represent any kind of character as a unique defined code that is specified as American Standards Committee on Information Interchange gave a specific number for that, which is commonly used worldwide, is helpful for us. Okay, that is the specialty we have. So we will be speaking about something called as the addition, subtractions, and other operations of in our upcoming video. I hope you have understood some basics that I wanted to present for you all. Thank you for watching, and don't forget to subscribe if you have not subscribed to this channel. Thank you so much.